stars, aren't they wondrous? But why are we talking about them? Well, we're talking about them because I have to take them in a few weeks. And also because if I don't, my grade is going to be really messed up. The star we're going to be talking about today is called deneb, and an important piece of information to know about deneb is what phase it's in and what happens in that phase. Deneb is currently in the Big Yoshi phase, or as regular people call it, the supergiant phase. During this phase, the star, in this case deneb, fuses hydrogen at its core until it is completely depleted of hydrogen. Once there is no more hydrogen to fuse, the star will instead fuse helium. Due to the star burning helium instead, they don't gain that much luminosity during this phase when compared to stars with a smaller mass. When putting deneb on an HR diagram, you must look for a few things. Those things are its color, magnitude, temperature, phase of evolution, and spectral class. Deneb is a white supergiant in spectral class A, has a temperature of 8,250 kelvins, and has a magnitude of around 10 to the 5th power, which is also 100,000. Because of this, deneb should go around the top where I marked it. Also, the color doesn't mean anything, it is just there to stand out, because if it was white like it should be, then nobody would be able to see it. The last part of this video is some facts about deneb. When looking at the lifespan of supergiant stars, the results can be pretty surprising. Supergiant stars like deneb live from 10 million years to 50 million years. This may seem like a lot, but comparing it to other types of stars, it's puny. For example, Bernard's star, which is a main sequence star, is expected to live for 7 billion years to 12 billion years. This is more than 10 times the amount of years supergiant stars are supposed to live for. The reason for this is because supergiant stars have much hotter core temperatures, which forces them to burn their fuel up faster, which also makes their life go faster. All comparisons in this section were made according to the sun. For example, the star is twice the size of the sun. This example is not the actual data. deneb actually has a mass of 19 times the sun, which is an absurd number, and its radius is 203 times the sun. This means deneb has a radius of 87,836,070 miles, or if you live outside the US, 141,358,452 kilometers. Deneb's elemental composition is composed of an abundance of carbon, nitrogen, oxygen, sulfur, calcium, yttrium, strontium, zirconium, barium, lanthanum, and europium. I'm also beginning to develop a lot of salt because of this. Bruh. Deneb is pretty hot if I do say so myself. In fact, it's 8,520 Kelvin / 4,890 degrees Fahrenheit / 7,976.85 degrees Celsius, which is
super hot, boy.
We actually don't know that much about deneb's current state, but we do know that it has stopped fusing hydrogen. Beyond that, many scientists are also saying that deneb is currently cooling and expanding. Breaking news! We have found the location of deneb and a picture of that location. Actually, deneb is without this red dude. deneb is destined to become our northern star. This will happen when deneb's core will stop using oxygen and every other element. Once that happens, it will cool and expand into a red supergiant. A few million years after that, there will be big boom, kabow, which will make it into a supernova. Like deneb's current state, there isn't that much known about what its future will entail. We will either have to wait for the future or make a time machine to see what happens.